So Bismillahirrahmanirrahim. Today we are going to discuss subject. For this foundation part, we have two different topics. Mustaba's side is, and from side it is the consolidation settlement. So for pile design, we have different kinds of pile. For example, we have audible.
Hello, sir. So we can't hear you.
Hello,
Hello, Hamza. We cannot hear anything from this.
audible now.
It's stuck.
Okay, sorry, there was some connection issue. So for foundation part, for this course, for this subject, there are two parts: foundation and pavement. So for this foundation part, we are going to discuss today. The foundation part, we have two uh, things to design, two topics. So first is pile design, and the second one is from the chairman side. It is consolidation settlement. So pile design is from Mustafa's side, and consolidation settlement is from the chairman's side. So for pile design, we have different types of conditions. For example, if our pile is in sandy strata, the second one is if the pile is in cohesive soil like clays. The third is if the pile, we have to find the uplift capacity of the pile. How much force would be required to uplift the pile. The fourth one is the group capacity of piles. What is the group capacity of different piles? And the fifth is the group efficiency of piles. The group efficiency. And the last one is we have the pile load test. So these six things, uh, they are included in this pile topic. First, we have to design in sandy, then clay, then the uplift pressure of or the uplift capacity of the pile. Then for grouped piles, we have two things. We have to determine its capacity, we have to determine its efficiency, and also we have to determine its settlement, the group settlement of the piles. And the last thing is the pile load test. So these six things or seven things are there. And for consolidation, we have three kinds of cases. The first one is over consolidated clays, normal consolidated clays, and in over consolidated there are two different topics. So we'll discuss this later on. First of all, we'll move towards the pile design. So what is a pile? The pile is a long, slender member. It is composed of a number of materials like steel or concrete or wood, timber, etc. So it is a long, thin member whose dia over depth over width ratio, df depth of pile over width ratio is greater or equal to 4. So this is a deep foundation, a kind of deep foundation. Pile is a kind of deep foundation. So how does the pile bears the given load? There are two different kinds of mechanism. First one is the tip of the pile. As the tip of the pile is in the contact with the soil, like soil is present in the at the bottom of the tip. So whatever the load we place on the pile, it is transferred to the soil at the tip. So we call this as base resistance. So the first one is base resistance. This is due to the tip of the pile. And the second one is due to the skin friction at the sides of the pile. There is some friction between the soil and the pile sides. So due to this skin friction, it is going to resist the applied load Q. So the second mechanism is the skin friction or shaft friction. So due to these two both forces or stresses, the pile is going to resist the applied load. So we can write our pile load ultimate capacity as sum of QB plus QS. The QB is the base resistance, the QS is the shaft resistance. So the combination of these two would give us the ultimate pile load capacity. And we can write the QB as QB, the stress at the base times the area of the base. QB times AB. The stress as a base times the area of the base. Plus, and QS is the frictional stress at the sides of the pile times the area of shaft, AS, area of shaft. So in each case, the QB and FS value would be different for both these cases, sandy, clay, uplift. The only difference is this QB and FS value. So these would change. AB and AS, they would remain the same. In the basic form, they would remain the same in all the cases. And what would be the area of the pile at the base? So at the base, the area of the pile would be, if the pile is circular, the area of the base would be pi d square by 4 simply because it is circular pile. And if the pile is rectangular, we can call the area of base as xy. For example, this is a cross section of the pile. One dimension is x, the other is y, so we can call it as x into y simply. And for the shaft resistance, if the pile is circular and rectangular, so if the pile is circular, the shaft resistance is the perimeter of the pile times its length. So for a circular cross section, the perimeter of it is always pi into d. This is the perimeter of the pile times its length. So this would be the shaft area, shaft surface area. Similarly, for the case of rectangular, the perimeter would be 2 times x plus y times L. So 2x plus y, 2x plus 2y into L, or 2 times x plus y into L. Or for square case, as x and y are same, so we can write it as 4 times some 4 times b into L. Where for square case, this is b, 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 b. All sides are b. So for square case, we can write it as 4 times b into L, or rectangular case 2 into x plus y plus into L, and circular it is pi into d into L. So any issue in this? This is a basic concept for pile design. And of course, after finding this allowable ultimate capacity of pile, we can find the allowable capacity as QU over some factor of safety. We can take factor of safety from 2.5 to 3. So this is the basic concept. So any issue in this?
No, Hamza.
All right. So if I draw a table, So if I draw a table, for example, the first type of our pile is the sandy strata. So for sandy strata, the second is clay or cohesive, and the third one is uplift. So for our sandy strata, our base resistance, so we know this AB and AS. Now we want to find about this QB and small fs. So for small QB and for small fs, only these formula would be different, the rest would be same. So for sandy strata, the small QB is equal to P dash into NQ. It is simply P dash into NQ. For shaft resistance for uh, in the sandy strata, it is P times Ks times tan delta. We'll discuss these terms for onwards. I'm just writing the formula. For the clay strata, our base resistance would be 9 times Cu and shaft resistance would be alpha times Cu. And for uplift, there are again two cases for sandy and for clay. So for shaft resistance, we ignore this base resistance. For uplift, we ignore this base resistance. Only we take this shaft resistance. So we'll take the shaft resistance of sandy as 2/3 of PSK tan delta. 2/3 of this value we are going to take, and for the uplift, we are going to take simply alpha times Cu. So these are the formulas for three types of piles: for sandy, for clay, for uplift. Sandy, we have base resistance as P times NQ, shaft resistance as P times Ks times tan delta. So let's start with the sandy. So our base resistance is P dash times NQ. So it is P dash. For example, if this is a pile, this is a pile. So at the tip of this pile, at the base of this pile, what would be the overburden stress? We'll call this as P dash. So whatever the pressure at the base or the tip of the pile, we'll call that as P dash. For example, at here the overburden pressure is 0. At here it is, suppose
Hamza,
this
again sound and screen is going to be struck.
the screen is struck. It is working on my side. Struck for other ones also. Any other person?
Yes, Hamza. I think university Wi-Fi is not working probably.
Okay, at which portion it is struck? Is it visible now?
Yes.
All right. From where it was struck? It was struck at which point? So is this table was fine?
This table.
Was this table understandable or not? So these are simply formulae.
Can you repeat
So
it
for
again? Can you repeat it again?
okay. So we discussed that there are different types of piles. Piles in sands, piles in clays, piles, and the uplift capacity of the piles. So for the formula for these cases, for sandy case, our base resistance would simply be P dash times NQ, and the shaft resistance would be P into Ks into tan delta. So what are these values we are going to discuss now? So what is base resistance? So whatever the pressure, so we can call the basis as QB, and it is P dash times NQ. So what is P dash? Whatever the pressure or the overburden pressure is at the base or at the tip of the pile. It is base resistance, so we'll call that pressure at the tip of the pile. We'll call this as P dash. Whatever it is at the tip of the pile, that is our P dash. So this is our P dash. And if the length of the pile is L and this pressure P dash at the bottom would be gamma times L. Simply the gamma is the unit weight of soil times the length of the soil. So that would be the P dash, the pressure at the tip of the pile. So this is P dash. What is NQ? NQ is the bearing capacity factor. Bearing capacity factor. And how we'll get this value? We'll get this value corresponding to different phi values. Phi is the angle of internal friction of the soil. So if we know the phi value, we can go to this table and we can find the NQ value. There are two types of pile, driven piles and bored piles. So if I draw this, so for example, if this is a strata, this is a soil. If you drive a ready-made pile through this strata like this, if we drive a pile through this strata, we'll call this pile as drilled or driven. That we have already constructed a pile, we are driving it through sand or clay or whatever. So this we'll call as drilled or driven pile. And for example, in the second case, if we have this sand, we have this bore. We have made a bore hole in the sand or the soil or whatever. After creating this hole, we are concreting it or we are placing a metal pile in this. So this pile will call as uh, whatever its name was, board pile. Yes, board pile. So this pile is the board pile. So first one is the driven pile. If we have already a prefabricated or pre-casted concrete pile or prefabricated steel pile, we are driving it in the sand or soil. So we'll call this a drilled or driven, and the second one is the board pile. So whatever the value of for the drilled or driven, the value of NQ for drilled or driven would be, we'll take its 1/3 for board. Why? Because board hole does not, it may have some gaps between its side. While the driven hole, we are driving it into the soil, so it would get quite a lot of load to drive it, and it would be tightly packed in the soil. While the board hole is simply resting on the bottom. There would be less skin friction in case of board hole. So whatever the value of NQ would for driven would be, we'll take its 1/3 for the board pile. So in here they have written the value of board, but if we move to this graph, they are saying that the value of NQ are for drilled piles. For board piles, it is taken as 1/3 of the drilled pile. So any issue in this? So we'll simply take the value of NQ from graph or table, take the P as the tip of the and multiply, and we'll get this B value. Any problem in this?
Whether these graphs or tables will be given or we should take it.
This will be given like usually at the back of the paper. This would be given, but most probably sir just give NQ value like in the questions. Like here in the question, they have provided that NQ value is this. So most probably it would be given like this. NQ value is this. But these graphs are simple. We'll go through this in the last question. They are saying that use this method, so we'll go through this in the last question. Okay, so the second one is the shaft friction, the shaft resistance or skin friction. So its formula is P times Ks times tan delta. We have to memorize these formulas, memorize this formula for sandy soils, P into NQ, and for the this was for the base resistance, and for the shaft resistance it is Fs P times Ks times tan delta. So what are P and Ks and tan delta? For example, again, if I draw a pile. So for example, if there are two layers of soil, for example, if we are considering this two layers, so or actually if we consider this one, we'll move to two second layers next. So if there is one layer of soil, what would be the P? The P would be whatever the average pressure is in the layer. For example, the pressure at the top is zero, we know. The pressure at the bottom is gamma times L, where L is the length of the pile. So the P would be the average pressure. So it would be 0 plus gamma times L over 2. So whatever the pressure, the average pressure is in the base, we'll take that as P. In the previous case, we were taking P dash as the base pressure at the tip of the pile. The pressure at the tip of the pile, simply gamma times L. Here we are taking the average pressure in the whole layer. This whole layer of the, for example, this is a whole layer of pile. We are taking the average pressure. So this is Fs. Ks is a little coefficient like in the previous one, DOS one. So we'll take this Ks. There are different formulae, but usually we take this as 1 by 2 Kp. The Kp is a passive earth coefficient, like in the DOS. We discussed in the DOS. So half of Kp we take this as Ks. So Kp is tan square 45 plus 5 by 2. This is the formula for Kp. If we take its half, we'll get this Ks value. Otherwise, there are also different values given for Ks. Like in this Ks is equal to 1 to 1.5 for driven, 0.7 for board, and this is 1.8, 1 minus sine phi, or 1 minus 1 into sine phi, 1 minus sine phi. So these are different values. We can choose any formula, but usually we take this one. Ks as 1 half of Kp. In question, they have also taken this formula. And the last thing is the delta. So delta is simply 3/4. 3/4 of 5. So whatever the angle of internal friction for the soil is, we'll multiply it by 0.75 and get the delta value. So this way we can get the shaft resistance. Any issue in this? Base resistance for sandy soils. This is the shaft resistance for sandy soils.
No issue.
So after, all right. So after getting these two resistance values or pressures, we'll get the ultimate load as QB times AB plus Fs times As, where QB and AB we get this from formula. AB is pi by 4 d square, like I discussed before, and As is pi dl for circular pipes. This is for circular piles. So for circular pile, these are the values. Simply after getting this QU, we'll get the QA as QU over factor of safety. So in each question for sandy, for clay, for uplift, we'll follow this whole procedure. Just the difference would be this QB and FS value would be calculated from different formula. Like I discussed in this table. So for sandy soil, we know these QB and FS values. For clay soil, the formula would change and the QB value would be 9 times Cu and the shaft resistance would be alpha times Cu. And for uplift, there would be no base resistance, only shaft resistance would be present, and it would be 2/3 of base resistance of sandy soils in case of uplift in sandy strata. And clay strata, it would be same as that of clay. So uplift and downward force, they would have the same shaft resistance. So only this QB and FS value would be changed. So that's why I have drawn this table. It is simpler to memorize in a table. So let's move to a question. For example, if we move to this question number 1. So for this problem number 1, we have this 12-meter long pile, 300 millimeter dia. The length of the pile is 12 meter. The dia of pile is 0.3 meters. The F, what is F? F is actually the phi. The phi is 40 degrees. They have written F as phi. So I is missing from there. So the groundwater table is at greater depth, so we are ignoring this. The unit weight is 18 and NQ is 137. So gamma of sand is 18 kilonewton per meter cube and NQ value is 137. So we have to determine its safe load capacity. We have to determine its allowable load capacity. So this is the data. So first of all, what should we do? First, we have to draw this pile. This is our pile. So for example, we know the length of the pile is 12 meters. So what would be the first step would be to calculate the overburden pressure. So we'll calculate the overburden pressure at the base. So I forgot one thing. There is a concept of critical depth. Critical depth, it is only applicable for sandy strata. For only sandy only. So what this critical depth concept says, it says that the pile, for example, if this is a pile, so the overburden on the pile does not linearly increase till the bottom. It is not like this. Actually, it is more like this thing, that it increases to up to a certain depth. We call this depth as critical depth LC, and after this depth is the overburden pressure becomes constant. So this is a critical depth concept. So it is simply empirical concept. For example, for loose sand, they say that LC is equal to 10 times dia of pile. For medium dense, or for medium, we can say LC is equal to 15 times dia, and for dense, LC is equal to 20 times dia. So this is the LC. So usually we take LC as 15 times dia. This is a conservative value. So we'll take this medium. But if it is given in the question that it is a loose sand, we have to take it as 20. We have to take it as 10. But if it is given as medium or dense, we can simply take as 15. No need to go for this 20 value because it is conservative. So first of all, what should we do? We should calculate LC value. LC is equal to, assume it is medium dense and 15 times dia. So 15 times 0.3, that is 4.5 meters. So what this concept says, that up to this 4.5 meter depth, up to this 4.5 meter depth, this overburden pressure would increase. After this 4.5 to the tip, this is 12 minus 4.5, that is 8 and 7.5. So after that, this would be constant. So this is the critical depth. So the overburden pressure at the top would be 0. At this 4.5 meter, it would be gamma into 4.5. 18 into 4.5, that is 81. So that is 81. And at the bottom, it would also remain 81. So any issue in this soil profile, overburden profile? Because you have to draw this in every sandy question, so it should be clear.
Okay, brother, no problem.
All right. So after this, what we have to calculate? We have to calculate QB, and the second case is FS. The same two things. So the QB is P dash NQ. Now P dash is the pressure at the base, because this is the base resistance. Remember, the P dash is always the base pressure. So at the base we have what the pressure is. This is 81. So 81 times NQ, 137. So this would be something answer. This is 11097 kilopascals. 81 kilopascals. So that is 11097. And for simply for Fs, what we have formula, we have P Ks tan delta. So P here is, if we look at this problem, so we have two layers. The first one is before critical depth. The second one is after critical depth. So in each case, the p value is changing. So what should we do? We have to divide this fs into two parts, fs1, fs2 for both layers. For fs1, our p would be 0 plus 81 by 2. This is the average stress in the first layer, 0 at the top, 81 at the bottom. Here, this one 81 and half it, average, get the average. And for P for the second layer would be 81 plus 81 by 2 because the pressure is not changing, it is constant. So this is P. The second thing is Ks. So Ks we can assume as half of tan square 45 plus 5 by 2. Otherwise, value would be given. If the value is not given, we can simply take this formula and find the Ks value. So it is like 2.23 or 2.3, like something like this. So times 2.3 times 2.3. For as long as the phi value does not change, the Ks value would be same. So in both cases, the soil is the same, so our Ks value would be same. The third thing is delta. So again, the delta value depends upon the phi value. So the delta value is delta is equal to 3 by 4 phi. So 3 by 4 into 40, that would be 30 degrees. So this way we can get the tan 30 degrees, tan delta into tan 30 degrees. So this way we can get the shaft resistance for both layers. So for example, it is coming like something I am assuming these values. For example, it is 23. It is like 115, for example, kPa, kPa. So one thing we have to take in mind, keep it in mind that this base resistance value, it should not be equal or more than 11 megapascal. That it should be less than or equal to 11 megapascal. It should not be more than 11. So if the value is coming over here greater than 11, simply take QB as 11 or 1100 or 11,000 kilopascal. So this is our limit. Uh, this we have to be more very much vigilant about this. That if the value is coming more than 11,000 or 11 megapascals, take this as 11. And in the same case here, if the value is coming more than 110 kPa, shower resistance 110 kPa, take this as 110 kPa. So in the first case, it is 23, so it is lesser than, that's fine. In the second one, it is 115, so we are going to take this as 110 kPa, not more than 110 here, and not more than 11 megapascal here. So is we have to be much more, very much conscious about this fact. Okay, so any problem in this part? Because this is only question we have to do. The rest is simple. Okay, so afterwards, if we have found the base resistance and the shaft resistance, simply Q ultimate is uh, QB times AB plus FS1 times AS1 plus FS2 times AS2. Where QB is like 11,000. Keep this in kilopascal units. Times AB is pi by 4 into zero point 0.3 square. 0.3 is the dia of the pile. Plus Fs1 is, for example, 23 kilopascal times pi dl. Pi times zero point 0.3 times the length of this layer. So the first layer, the length is 4.5 meters. So times 4.5. This is the length. The last thing is Fs2. So 110, we are not exceeding 110 times pi times zero point 0.3 times 7.5. So this way, simply multiply and get the QU value. The Q allowable, what required in the question is QU over factor of safety. Factor of safety simply assume 2.5 if they have not given. Factor of safety is 2.5. So simply we can get this as 2.5 Q allowable. So this way we can solve this question. So any issue in this one? The
No
second
issue,
one
sir.
is all right. The second one is quite much similar. So we have dia of pile as 1 feet 12 inches, length is 45 feet, and water table 10 feet, water table at 10 feet. So KS 1.5, 532, KS equal to 1.5, phi is equal to 32, and gamma 110 FS 2.5. So this is our pile. So first of all, what would we do? The first step for sandy soil is always calculate LC, the critical depth. That is simply 15 times dia or 15 feet because the dia is 1 foot. So after calculating, draw this diagram, the pile diagram. So we know that for the top of the pile, the 15 pile, 15 feet, we'll have this critical depth. So we have divided our pile into two layers. But if we look in the question, we are also given that water table is as 10 feet. So we have this also water table at 10 feet. So we have three layers actually, one, two, and three. The first one is of 10 feet water table. The second one is 5 feet. And this is our critical depth LC. And the last is the rest remaining portion of the pile. That is 45 minus 15. That is 30 feet. So our overburden pressure, what would it look like? At the top, there is 0. At this point, it is 10 into 110 simply. So this is overburden pressure at the top of the water table. After water table, we are going to use gamma submerged values. So what would be it like? 10 to 110, it is like 1100 plus gamma is 110 minus gamma W 62.4 times the depth of this layer 5. This is gamma times df simply. So we'll get some value like 1338. And after the critical depth, our stress would remain constant. So at this step, it would be also 1338. This way, we have to draw this overburden stress profile. At the top, it is simple gamma times depth 10 feet. After water table, we have to subtract gamma W. We have to, gamma saturated, gamma submerged is equal to gamma saturated minus gamma W. So from gamma saturated, that is 110, we have to subtract gamma W, that is 62.4 in FPS, multiplied by 5, we'll get, and add the previous overburden, we'll get the this layer overburden, and simply get, because this is the critical depth, after this depth, stress value would become constant, overburden value would become constant. So after calculating this overburden, first step same, calculate QB. QB is P dash into NQ. We has 1338. NQ we are given. No, we are not given, so simply take the NQ 32. NQ is 29. So simply we'll get QB value like this. The second thing is FS. So we have three layers, so we'll get three FS, three skin frictions. So FS1, FS2, FS3. So for FS1, we have T as 0 plus 1100 by 2, the average stress in the layer, times KS. KS is given as 1.5 times 10 3 by 4 into 10 delta 3 by 4 into 5. So delta is 3 by 4 into 5, so 32. So simply multiply, get the answer. But second layer, only the stress would change. The set stress would change from 1100 to 1338. 1100 plus 1338 over 2 times this is this portion will remain same. Now for the last layer, it would be like 1338 divided by 2 times the same, because Ks and tan delta are not changing. So we'll get the Fs value like this. Remember the limits for these values. So the limit for in FPS unit, it is 230 kips for QB and 23 kip for FS. Remember, for all these FS values, they should be less than or equal to 23, not more than that. And for QB, it should be less or equal to 230 kips, not more than that. Just remember. After getting these, QU is QBA, simply QB plus QS. So QB is QBAB. QS is FS1 ES1 plus FS2 ES2 plus FS3 AS3. So this is pi by 4 d square simply. FS1 AS1 is pi d. Pi into d is we have 1 fit. This is also pi into 1. This is also pi into 1. And the length for each layer is 10, 5 and 30. So multiplied by 10, multiplied by 5, multiplied by 30 simply. And get the answer. The Q labor would be QU over F factor of safety. So this way we can solve this question. Any issue in this?
No, brother.
All right. So the last question is this is for different strata soils. So for example, this is our pile, and now it is in 3 different kinds of sandy soils. So in this case, we can or we cannot. We It is up to our choice. We can or we cannot use a critical depth concept. If we want to, we can. If we don't want, we can we cannot do. We should not do simply. So it is up to our own discretion that if you want to use critical depth, use it. Otherwise, don't use it. But uh, it is preferable to use for sandy. If all the layers are sand, use this. If any layer is any of this, for example, this it was clay, do not use the critical depth. Critical depth is only applicable for sandy layers. What I meant to say is if all the layers are sand, just use critical depth. If any one of the layer is a clay layer, don't use critical depth concept. So first of all, we have to find the LC. LC is simply 15 times dia because all the layers are sand. Dia is 45 centimeter or 0.45 meters. 15 into 0.45, that is 6.75 meters. So this is a critical depth. This is a 6.75 meters. And the layer properties are given 8, 6 and 2 meters heights. So this one was 8 meter. So if the 6 meter is above, 6.75 is above, this is 1.25 meters. The second layer is 6 meter. The third layer is 2 meters. So first layer, second layer, third layer, and this is a fourth layer. Fourth layer is 2 meters. And water table, we have the water table at the top of the soils. So the water table is the top of the soil. So all the gamma values we are going to use gamma submerged values, not gamma saturated values, not gamma dry values. So for each layer, we are given some things. We are going to make this table. So for layers, this is layer 1, this is layer 2, this is layer 3. So for layer 1, we are assuming this whole as layer 1 for sand layer 1. We are given gamma D values, we are given phi values, we are given E values. So layer 1 is 16.5, 30.6, 16.5, 30.6. Layer 2 is 15.5, 35.65. 15.5, 35.65. The last one is 1638.65. 1638.65. So this all values are given in the question. This is all the given data. What we have to find is now we have to find gamma submerged. We have to find gamma submerged. What is gamma submerged? Because water table is at the top of the soil layers. So we are going to use gamma submerged. Gamma submerged is gamma saturated minus gamma of water. So we know gamma water is 9.81. We do not know gamma saturated. So for gamma saturated, the formula is the formula relating gamma saturated is Gs plus E over 1 plus E into gamma W. So this is the formula for gamma saturated. We have to memorize this. We have to memorize this formula. So it may or may not be given in the paper. So Gs plus E over plus E into gamma W. Now if you look in this formula, we know the E values. We have provided us E values. We know the gamma W value, that is 9.81. We do not know Gs values. So where we'll get this Gs value? Simply we know this gamma D values. So we know the formula gamma D is equal to Gs over 1 plus E into gamma W. This is the formula for gamma W. If we rearrange this formula, it would be like gamma D into 1 plus W, 1 plus E over gamma W is equal to Gs. So something like this. If we plug in the gamma D, know this value. If we plug in E, we know this value for each layer. Gamma D, E or phi are known, and gamma W is 9.81 in kilonewtons. So we'll get the Gs value. The fourth thing what we have to find is Gs value. From using this Gs value, we'll find this gamma saturated. Gs plus C 1 plus C into gamma W. So gamma saturated, and using this gamma saturated, we'll find gamma submerged. Gamma submerged. So any issue in this? Or we are going to find gamma submerged for if the data is provided in such a way. Calculate GS, calculate gamma saturated, calculate gamma submerged. So after calculating gamma submerged, what we require for each layer, if we recall the formula for the skin friction, because base friction is always for one layer, the skin friction is for different layers. So skin friction is P into Ks into tan delta. So we require Ks and tan delta for each layer as well. So simply Ks would be half times tan square 45 plus 5 by 2. We know phi, we can simply find Ks for each layer. And delta, we know phi again, so delta is 3, 4 of phi. So this way we can get Ks and delta for each layer as well. So just make a table like this. The first three values are known. Using these, calculate Gs as gamma W 1 plus E over gamma D 1 plus E over gamma W. Yes. Gamma saturated is Gs plus E over 1 plus E into gamma W. Gamma submerges gamma saturated minus gamma of water. So if we find all this for different layers, now we can use this critical depth concept, because if we know this gamma saturated values, gamma submerged values, we can find the overburden pressure. So any issue in this table before we move onwards?
Okay.
All right. So after calculating this gamma submerged values, now we are going to use these values to calculate overburden pressure. So at the top it is 0. At here it is, suppose gamma submerged value for first layer comes out to be something like 10, this 9, this 9.5 something. Because it is gamma submerged, it would be much lesser than the gamma values. So for the first layer, we have this 10 gamma. So 10 times this 6.75. 6.75 times 10. This the length of the critical depth is 6.75. So afterward, this is 67.5. So afterwards, we know this, that after critical depth, the stress becomes constant. So simply we'll move like this, and at the bottom it is again 67.5 simply. So at each layer it would be simply 67.5, 67.5. This is all constant. So we have determined this stress values. Now for base friction, we can simply use QB is equal to P dash NQ, where P dash is at the tip of the base, that is pressure at the tip of the base, 67.5 times NQ. Now we don't know this NQ value, but we know the 5. Yes, now they are saying that use this Bayesian test something something. Well, use this method for calculating QB. So if we move to the chart like this, so this is his chart. So in this chart, if we know these 5 values, we can find this NQ values. Simply if we know this 5 value, we can find this NQ value. So which 5 value should we use? Should we use 30? Should we use 35? Should we use 38? We have 3 different values of phi. So we have these 3 different values of phi. What value should we use for base? Any ideas? So we are going to use the value of the phi where the tip is. Remember, the tip is at the bottom. So whatever the strata where the tip is, we are going to use the phi of that strata. So at the bottom layer, we have so for at the bottom layer, we have this phi value as 38. In the tip layer, we have the phi value as 38. So we are going to use this 38 value. Phi value, we are going to use this 38 for this NQ calculation. And the second thing required for this graph is L over D ratio. So length over dia ratio. The length we know the graph, this length of pile is something like 6 plus 2, 8 plus 8, 16 meters. Over dia of pile is 0.45, 45 centimeter, 0.45. So something like 35 comes from this calculation. So if we move to this chart, so we are given this L by D ratio for 70. We are given this L by D ratio for 20. So 35 lies almost in between these two, 70 and 30. So we can interpolate a curve between them. Simply draw a curve between these two, or simply you where the 38 value would be like this. 38 move to the top, and in between these layers simply stop, because we know that the L by D ratio for 35 would be something in the middle, and calculate this NQ value for this layer. So approximately it comes out to be 100. That is quite, we can round about this something. So we can get this NQ value from that method. So for the above method, it is again the same. If we know this phi value, you can simply get this NQ value. This is simpler. No L by D ratio required in this question. And third is this, we can use this phi tables. For phi values, we can get this NQ values. Alright, so this way we can get this QB values. After getting these QB values, we have 4 layers, so we'll get FS1, FS2, FS3, FS4, 4 skin frictions. So FS1 is P into, so P value for FS1 is something like 67.5, 0 plus 67.5 by 2. And in the all the next layers, if you look at this, the value of P becomes constant. This question, the value of P becomes constant because this is below the critical depth. So we can simply write 67 plus 67.5 divided by 2, or 67.5 or 67.5, because the value of the P is same. It becomes constant. This times Ks. So Ks we have calculated from this table for this. For example, it is 1.5, 1.8, 2.1. We calculate this formula. So we are multiplying it by formula 1.5, 1.8, 1.5 for first 2 layers, 1.8 and 2.1, because these 2 layers have the same soil. Only because due to critical depth we have divided it into 2 parts. The last thing is tan delta, so 3 by 4 of 5, 3 by 4 of 30, 3 by 4 of 35, 3 by 4 of 38. Tan 3 by 4 of 30, tan 3 by 4 of 35, sorry 30, tan 3 by 4 of 35, tan 3 by 4 of 38. So simply this way we can get Fs simply multiplied by get Qu value, QbAb plus Fs1 As1, Fs2 As2, Fs3 As3 plus Fs4 As4. Simply, and Q allowable would be Qu over factor of safety. So that is simple. So only the thing different is this Fs and Qb. If we know how to calculate this, we can simply solve the question. It becomes much easier. So any issue in this? How to solve different layers? So afterwards, if there is no issue, we have the this was all for piles in sandy strata. The second one is piles in clay strata, the cohesive soil. So in clay strata, just like I mentioned before, the only thing would be different would be Fs and Qb. Fs and Qb. So we have two methods for clay. The first one is alpha method. For alpha method, our QB is simply 9 times Cu. Just memorize this. QB is 9 times Cu and Fs is alpha times Cu. So what is this alpha? This is some constant is between 0.3 to 1. If we are not given, you can assume this as 0.5 or otherwise we are given in the question. There is no issue in this. What is Cu? Cu is an undrained shear strength. Undrained shear strength. So undrained shear strength. We can call this as Cu, we can call this as Su, we can call this as USS, undrained shear strength. So if any of these values are given, they all mean the same. So what this means, for example, if you perform an undrained what was it, triaxial compression test, undrained compression test, UCT test, undrained compression test on clay sample. So what would we get? We get a Mohr circle like this one. So the radius of this Mohr circle, this is the radius of this Mohr circle. This is Cu, undrained shear strength. The diameter of this Mohr circle, this is undrained compressive strength, UCS value. So Cu value would be simply, as this is the radius, so UCS value divided by 2. So if we are given compression value, C means compression, undrained compression strength, compressive strength. If we are given this compressive strength, simply divide by 2 to get this Cu value. Otherwise, if they are given undrained shear strength, simply that is simply Cu. So shear strength is simply Cu. The compressive strength divided by 2 is Cu. Alright, just keep this in mind. So simply use this value and get the answer. So if we are given this question, so problem 1 post, we'll discuss second method onwards. So 18 times 18 inches is the dia. Dia is 1.5 feet, 18 inches, 50 feet long. Their length is 50 feet. The groundwater table is at the ground. We do not, for alpha method there is no use for this groundwater table. Undead cohesion. So undead cohesion is Cu. Also cohesion is also Cu. Cohesion is also cohesion. Cohesion is also Cu value. So undead cohesion Cu is 1050 pound per square feet PSF. The lasting alpha 0.75 and 2.5. So this is all values given. So alpha method is very much simpler. We do not need to calculate critical depths. No need for that in clay soils. We do not need to calculate overburden pressure. There is no use in alpha method. Alpha method is simpler. Simply QB is equal to 9 times CU. So 9 times 1050, simply we'll get this QB value. Again, QS value is equal to alpha times CU. So 0.4 times 4.45 times CU, and we'll get this QS value. Remember, there are no limits in clay strata. Whatever the value is, just take this as it is. There are no limits of 11 megapascal or 110 kilopascals. So after getting the QB and QS, what what should we do next? Simply QU is equal to QBAB plus QSAS. Using this formula, Q allowable is QU over factor of safety. Factor of safety is 2.5. So using this, we can get this answer. So this is very much simpler. Any issue in this?
No, brother.
Okay. So in the second question, if you look, so they are given this unconfined compressive strength. Remember, if it is compressive, there is any word of compressive. This means UCS value. UCS value is 4.2 KSF, kS per square feet. For CU value, we require the CU value. This is UCS by 2. That is 2.1 KSF. So remember, we are going to use CU values always, not UCS value. So only this thing is different in this one. The rest is same. Yes, one thing also different, that we do not know the length of the pile. We know this allowable load as 90 kips. So in this question, problem number 2, we know this Q allowable as 90 kips. So but we do not know the length of the pile. So if we use the formula Q allowable, that is Q ultimate over factor of safety. So Q allowable is 90 times factor of safety, that is 2.5, I think, is equal to Q ultimate. So we know this Q ultimate as QBAB plus QSAS, where this QB is simply some value. This is 9 times CU, 9 times 2.1 KSF, into AB is pi d square over 4, pi d square over 4. D value is given in this question, 18 into 18. So oh yes, this is 18 into 18. This means this is not a square, this is not a circular pile. They are given the pile as 18 times 18. That means 1.5 feet into 1.5 feet. This is a square pile. So the area of square piles would be simply 1.5 into 1.5. So remember this, plus. Now QS for this is alpha times CU, whatever the value is, and the AS for the square uh, cross section. For example, if one side is B, what would be its perimeter? The perimeter for the square is 4 times B. And if we multiply this by L, we'll get this surface area. So perimeter times L. Pi dl means pi d is the perimeter times L, the surface, it becomes the surface area. So here this is 4B times L, in this becomes the surface area. Now we know this B value as 1.5 feet. B value is 1.5. We do not know this L value. So this is our variable. So if we simply use this equation, we know the CU value, we know this alpha value, CU value given, we know this B value. So only the unknown in this question is this L value. In this equation is this L value. So simply if we can get this from this equation. So simply we can get the L value from this equation. So any issue in this one?
No, brother.
So all right. So after this one was alpha method. The second one is beta method. Beta method is a bit more accurate method, but it requires a bit more calculations. Alpha method is conservative method. So beta method is we have this the QB is the same, 9 times CU. The FS value would be different. That is beta times sigma Z naught. And where the sigma Z naught is exactly the same, the average stress in the layer, average stress in layer. Like in sand, we calculate the average stress in there. This sigma Z naught is exactly the same. This is the average stress in that layer. and beta value is simply k times tan phi r. Phi r is the remolded clay angle. The phi like angular friction of remolded clay. So we have two types of samples. First is the undisturbed sample or UDS. UDS is the undisturbed sample. We can get the undisturbed sample of clays, but we cannot get the undisturbed sample of soils because of sands because they would fall apart. They have no cohesion. But and the second thing is remolded sample RS. So this sigma R is the remolded angle of friction. So we'll be provide this value. So if we look at here, so they say that it is between 20 and 30 and will be provided this value in the question. And beta, and if what beta value is, so phi r is a remolded angle, what the k value is? So k value is 1 minus sine phi r. So k value is 1 minus sine phi r for NCCs. So for NCCs it is 1 minus sine phi r. For OCCs we'll discuss this in the consolidation part. So we do not need to use this equation. If we want to be more accurate, we can use this equation. Otherwise, if we assume the soil is NCC and use above equation, we can simply be a bit more conservative. So if they have specially mentioned in the question that OCR is equal to this, they are specially mentioned, then use this equation. Otherwise, use the above one. Okay, so this way, first calculate K, then calculate beta, then calculate Fs for that layer. So after getting the Fs for that layer, simply use this before formulas, calculate Qu and Qb allowable. So for example, if for a 3 strata layer, if we use the beta method, this is exactly the same as what we discussed from sand. Simply Qb here would be simply 9 times Cu. So what Cu value would be used? We will use the Cu value where the tip is lying. Like in the sand, we use the phi value where the tip was. Now we'll use the Cu value for the tip. So 9 times 105 will get this QB values. For Fs value for each layer would be different. So Fs1 is equal to alpha 1 Cu1. So alpha 1 is simply 0.9 into 30. Alpha 1 Cu1. So Fs2 alpha 2 Cu2, alpha 2 is 0.75, Cu2 is 50. Multiply will get this Fs2. Fs3 is alpha 3 C3, so zero point 0.5 into 105. So just this whole question would take hardly 4 to 5 minutes. Simply calculate QB and 3 Fs, add them, multiply them with these areas and add them and divide by factor safety 2.5. We'll get this Q ultimate and Q allowable. Okay, so this is quite simple question. For clays, it is quite simple, especially alpha method. So if we use this, if we see this problem, they have provided us that you can calculate alpha from this formula. Alpha is equal to 1 minus 0.5 SU. SU is the same as CU minus 25 or 50. So we can use this formula to calculate alpha 1, alpha 2, alpha 3, and using these alpha values, simply like this question, we can calculate the ultimate and the allowable bearing capacity, pile capacity. So this is all for alpha method. So for beta method, if we solve this for beta method, this becomes a bit more complex. Why? Because we have to find the overburden pressure. So if, for example, they're saying water table has 10 feet, then 15, 25, 25. So for example, if we have this pile, so we have this water table at 10 feet. So after this layer is 15 feet total, so this means 5 feet and 25 feet, and the last layer is also 25 feet. So this is the values given. So for the rest is given as U for 20, 40, 60. So if I draw a table like before, it is better to draw a table in this question. for different layers, it becomes much more simpler. So layer, we have now 1, 2, 3, 4. We have 4 layers, or actually we have, yes, we have 4 layers. So we have layer 1, we have layer 2, we have layer 3, we have layer 4. So for layer 1, the first thing we have to find, we have to tabulate is CU values. CU value is 20 for layer 1, 40 for layer 2, 60 for layer 3. We are dividing layer 1 into 2 parts because of water table. This is actually whole is layer 1, but we have divided into 2 parts because water table is between the layers. So after CU value, what have we have gamma values. Gamma 110 for first layer, second 110, and gamma saturated to 120. Gamma saturated 125, 130. 125, 130. So we find gamma submerged for water table, for the layers below water table. The first layer is above water table, so it would remain the same. This is below, so 120 minus 62.4. So something like 62.4, like 58 or 57.6, something like this. So just calculate gamma submerged. That is gamma minus 62.4, the gamma W. Remember, only for those layers which are below the water table, these 3 layers, not for the first layer. After gamma submerged, what we have to find, we have to find this for beta method, we find this K value. So for K value, we have to be given phi R value. Sir have told us the phi R values for this question. They are not written on the slides, but they were dictated by sir. So for the first layer is 22. This is for 22. This is for 20. Second layer. This is for 26. So we have 3 layers, and K value would be simply 1 minus sine phi r. So we will find the K values by 1 minus sine phi r. 1 minus sine 22, something like 0.63. This like 0.60 same. This may be like 0.59. This may be like 1.56, like something like this values we can calculate. So after K, what we require this beta value. Beta is K tan phi r. So the next column we are going to add is beta value. That is K tan phi r. Simply multiply this K with tan of this 22. So we'll get this tan 22. This is 2.25. 0.25. This will be like 0.26, like 0.248, like 2.29, something like these values. So if we look at here, the K value usually vary from 0.246 to 0.259, 0.29. So some values would be generated for these K values, for these beta values. Okay, first we place the CU values, then the gamma values are given. After that, for the layers below the whatever, we calculate the gamma submerged. For I value also given, we calculate K values and we calculate beta values. Now we are going to use the beta method. So the beta method is the same as that of sandy soil. We require this overburden pressure. So the first layer is this, the second layer, the third layer. This is the water table layer, and this is the fourth layer, whatever. So for overburden, what would be the overburden in the first layer? 0 to, this is like 10 feet, this is like 5 feet, 25, 25. So 10 times first gamma, 110. 10 times 110, that is 1100. This is 1100. So here no critical depth concept would be used. Only we are going to add. The second layer, if we find this, we suppose that gamma submerged was almost 50. So 100 and 1100 plus 50 is 7.6 into this layer thickness 5. So the third layer would be this whole value plus 25 into this gamma value. This, for example, if we suppose this as 50, this is the gamma submerged. So we'll multiply this. The last value would be again this whole sum plus 25 into this gamma value. So this is suppose 60 value. So this way we can get the overburden pressure. After getting the overburden pressure, the thing is same. Fs1 is equal to beta 1 sigma z1. So beta 1 we calculate this way 0.25. Sigma z1 is simply average of the first layer pressure. 1100 plus 0 over 2. Simply this way beta 2 into sigma z2, beta 3 into sigma z3, beta 4 into sigma z4. This way you can get fs2, fs3, fs4. So this beta method is a bit lengthy, but it is quite similar to the sand method. So any issue in this? Simply multiply beta with the average pressure in that layer. No, so the last one is the uplift capacity. So for uplift capacity, we have again two cases for sands and for clays. The basic formula for uplift capacity is Pu, pull out capacity is QFP over factor of safety plus weight of pile. Q uplift is what the force is pulling upward. Pu is pulling upward. So the weight of the force is against this. So it would resist this uplift capacity. So we are adding the weight of the pile in this one. So Pu would be QFP over factor of safety into weight of the pile, where the QFP is again the same. So weight of pile QFP would value would only different for these two cases. QFP that is percent. What was our FS value? FS into AS. So only second friction is going to be used because it is moving upward. So no resistance would be required by the base. So QB value is 0 in this case. So in the second case, if you remember, the FS value was P into Ks into tan delta. This was the FS value in case of sands. We have to just multiply it by 2/3. We are going to take 2/3 in this case because it is uplift, it is moving upward. So we are taking a conservative value. Multiply it by AS and get this QFP. In clay case, the value was for pure clay for the downward force, it was alpha times Cu. So now we are going to use this alpha times Cu, no factor of safety times AS. So in clay case here again going to use this alpha times Cu. So any issue in this? The only issue is only thing is that QFP value is different. QFP value is same. Just we have to memorize that in case of sand, it would be 2/3 of the downward one. So if we look in this problem, this saying that the length of pipe 30 feet, die is 25. Length is 30 feet, die is 1.25 feet. So using this length and die, first calculate the weight of the pile. The weight of pile simply would be gamma concrete times area times length times volume. So the volume is area times length. So gamma concrete we can take in FPS unit as 150 pounds per square per cubic feet. Area is pi by 4 into 1.25 square, where the length is 30 feet. Simply multiply these, get the weight of the pile. After this, get to the pile, what values we are more provide? We are provided this Cu and Fs and alpha. So Cu value is 2500, factor of safety is 2.5, so is 3, sorry 3, alpha is 0.4. So We know the pull-out capacity is QFP over factor of safety plus weight of the pile. For example, the weight of the pile comes out 5,000 pounds. So we'll use this QFP as alpha times Cu times area of pile. So alpha is zero point 0.4 times 2500 times Cu is times alpha pi area of pile is uh, pi into 1.25 into 30 divided by 3 times 5,000. So this way you can get the pull out capacity for clay pile. This is Fs. This is area of pile. Any issue in this one?
No, brother.
Okay. So the second question is simply for the sandy piles. Just the differences. So 30 feet, 25 feet, the same. So weight of the pile would be same approximately because the length and dia are same. Phi is 30 ks is equal to 1.5. Fs3 the gamma of sand is 110. So this is given. So for sandy soils, the formula for pulled out capacity is QFP over factor of safety plus weight of the pile. The same formula where the QFP would be changed. That is 2/3 of P times Ks times tan delta over factor of safety, that is 3, plus weight of the pile, that is 5,000. So here, what is the PP? The average overburden pressure. So here we do not need to use the critical depth concept. We can simply find the average overburden pressure at the bottom. So if the zero was at the top, at the bottom it would be 1 times length of the pile. This is 30 feet. So 30. 1 minute. Okay. So simply the P is the average overburden pressure in that layer. Simply it is the average of the top and bottom stresses. Ks we are provided as 1.5 and tan delta is tan 3 by 4. Delta is 3 by 4th of pi. Simply if we divide it by factor of safety 3 plus the weight of the concrete portion of the pile, we'll get the pull load capacity in sandy soil. So any issue in this pull out capacity or the sandy or the clay? Because these all are similar, just the difference is the difference in the formulas. So if you memorize, if you try to, I find it easier to memorize in that formula table. So if you draw a table and just try to memorize, this is quite simple. This is, summary is quite simple. Any issue?
No.
All right. So after this, all is for this concludes the portion for individual piles. It's all for individual piles. After this, we have okay. Oh, sorry. So we have two things left. We have this pile capacity based on SPT values, and we have pile capacity based on CPT values. CPT and SPTs are two tests. SPT is standard penetration test. CPT is cone penetration test. So we use this test to determine the soil strata. So we can also determine the pile capacity from this soil strata, the required pile capacity. So these the question of SPT is given in the uh, here in the slides. Sorry, for CPT is given the slides. For example, for CPT, it is quite simple. If I 1 minute, just let me get the data. So for CPT values, we are given with the length of the pile. We are given with the dia of the pile. So the length of the pile and the dia of the pile. We are also given with the QS of shaft and QS of base. This QS of shaft and QS of base, these values are coming from the SPT test directly. We don't need to calculate this. These values would come directly from the CPT test, not SPT. This is CPT test. So the dia of the pile is 0.4 meters. The length of the pile is the length of the pile is unknown. We are given with the allowable weight as 1650 kilonewton. The allowable load that the pile is going to 50 kilonewtons. The QC of shaft is 4 kilogram per centimeter and 120 kilogram per square. This is QC of shaft, not QS of base. C means CPT test. This value, this whole data is given. So first of all, you have to make the units consistent. So if we want to convert this kilogram per centimeter square into kPa, so multiply it by 100 kPa. Simply multiply it by 100, we'll get the value in kilonewton per square meter. So 4 into 100, that is 400 kPa, and 120 into 100, that would be 12,000 kPa. So this QC of shaft is actually Fs. This QC of base is actually uh, QB. So these are actually direct values we can get from uh, CP test. But what we have to do, we have to divide this by 2. This Fs value is QC by 2. So 400 by 2, that is 200. So Fs value we have to divide by 2. The QB value is same as the QC shaft, QC base value, that is simply this. So we have Fs value as 200 kPa and QB value as 12,000 kPa. So our limits, remember the limits. So our limits were this is greater than 110 kPa and this is greater than 11 megapascal or 11,000 kilopascal. So we are going to use Fs value as 110 and QB value as 11,000 for sandy strata. This is sandy strata. Okay, if we after limiting this again, we do the same thing. We know Q label is equal to Q ultimate over factor of safety. Q label into factor of safety is equal to Q ultimate. That is equal to QB plus FS AS. So Q label is 1650 times factor of safety is 3, I think, times QB is, we have QB as 11,000 times pi into zero point 0.4 square over pi d square by 4 plus 110 into pi dl, pi into zero point 0.4 into length. So again, calculate the length from this. Only unknown is length. Calculate the length from this formula. Okay, an issue in this CPT value. Alright, so for SPT values, it is a bit uh, lengthy procedure. The procedure is exactly the same, but it is a bit more lengthier. So for SPT values, we have to construct a table. Actually, we would be given a table for some depth d in meters. We are given the n values. The n values we are obtained from the SPT test. So example d is 1.5, 3, 4.5, 6 or 7.5, so on. Full table is given, and the n values are given as, for example, 4, 6, 13, and so on. Some values of n are given in this way. So first of all, what we have to do, we have to find n average. So n average is the average of n values of that layer and of the above layers. The average n values of including that layer and the above layers. So for example, in the first layer there is only one layer, so the average value would be simply 4. For second layer, we have these two values, 4 and 6. So the average would be 4 plus 6 over 2. That is 10 by 2, that is 5. For the third layer, we have these three n values, 4 plus 6 plus 13 divided by 3. So that is 13 plus 10, that is 23 by 3. So that is about 7 point something, 7.67. So we'll round it to a whole number. So we'll take this at 8, round it to the nearest number. So this way we can get this n average values. First, we have to find this n average values. Then we have to go to this QSFS formula. So the FS formula is 2n. And the FS formula is simply 2n. Fs is the shaft friction. So Fs value is 2n. Remember, n here is n average, because remember, for shaft friction we use the average stress. Again, we are going to use the average n value for the shaft friction. So simply the pile is 0.45 meters into 0.45 meter. It is a square pile. So it is given the question, it is a square pile. So 2 times n, 2 into 4, that is 8, 2 into 5, that is 10, 2 into 8 is, that is 16. This way we can get the Fs value. Okay, so afterward we have to find Qs. Qs is Fs As, or Fs times pi dl for circular shafts, and simply 4 times b into L for square shafts, where the b is 0.45 meters, 0.45 meters. So simply calculate this. Now for first layer, the Fs is 8 times 4 times 0.45. And what would be the length? The length of the pile is not given. We will use the length of the pile up till the depth. Up till the depth we are calculating, we are going to use that as the length. So for here the length we are going to use as 1.5. The second part, we are going to use 10 into 4 into 4.45. This part would remain same, and the length would change to 3. Similarly, 13 into 4 into 0.45 times length is 4.5. This way we can get the QS value for SPT tests. Any issue in this one?
No, brother.
Okay. So after this QS value, we have to find the QB values, the base. So the QB value, the formula for QB is 400 dB over D. This one, 400, sorry, 40 N into dB over D. So 40 N into dB over D, where dB is the depth of bore, D is dB is the diameter of the D is the diameter of pile, dB is the depth of the bore, the length in the soil or the depth of the bore. So we know this D as 0.45 because it is a square pile. So what we are going to do, we are going to simply multiply the n values, and 40 times n times dB we have first for first layer, it is 1.5 over 0.45. And remember, now the n values, we are going to use the n value for that layer only. We are not going to use average n values in this one, because the dB value is at the bottom of the layer. It is a base distance. So we are going to use only that layer's n value, not the average one, only that layer. So for the first layer we have average, for the first layer we have the n value as 4. Similarly, for second layer, 40 times n value is 6 times 3 over 0.45. Third layer is 40 times 13 times 4.5 over 0.45. So so we are not going to use average value. We are going to use simply the value for that layer here. In skin friction, we used average. In here, we are going to use that layer only. So after this, they have said that its value should not be more than 400 times n. This value should not be more than, the limit value is 400 times n. It should not be more than 400 times n. So for first layer, 400 into 40, so 400 into 4, that is 1600. For second layer, it is 400 into 6. The n value for that layer, 2400. Third layer is 400 into 13, that is 48, and 52,200. This is the limiting value. So the Q selected value, QB selected. What we are going to select? We are going to select the minimum value out of these two. For example, the first layer value was 1300. This is 2400. And this one is like 6000. So we are going to select the minimum from these two. The minimum from these two is 1300. From these two, they are both equal, 2400. From these two, it is 5200. So that is the QB selected. Okay, so we are going to select the minimum. We are going to select minimum of these two. Minimum of these two. So after this QB, the last thing is capital QB, that is QB times AB, where AB is pi by 4 into D square. D is sorry, this is a square file, so our area of base would be 0.45 into 0.45. Simply multiply the something. Simply multiply this area, this QB with this area, we'll get the QB values for each layer. Any issue in this? First simulate QB. All right. Then calculate the maximum times QB. Maximum would be, limiting would be 400, and select the minimum out of these two and multiply it with the area. Now we know this QS. Now we know this QB. Simply QU is equal to QB over QB plus QS. QB plus QS, we know these two values. Simply add them, we'll get this QU, and simply Q allowable would be QU over factor of safety. And the Q in tension, the tension capacity we can conservatively assume as 0.1 of QU. Either would be given this value, or or we can assume this as 10%. So we can take this as 0.1 times QU. So we can get the pile capacity in tension also from this SPT test. So this is all SPT test. We have to create this whole large table, and we have to use the formulas to calculate this. So any issue up till this part? This all concludes the part for individual piles. Okay, so if there's no question, the second thing in this pile topic is pile group of piles. So for example, if this is a pile group, this is 1 2 3 4, 1 2 3, 4, and 1, 2, 3, 4. So this is a pile group. So if we look at this picture, so pile group, where was the picture? So I think there is no picture here. Maybe here, or maybe here. So if you look at this is a kind of a pile. This is a pile group. So if you look at this picture, this whole is the pile cap, and these piles, 1 pile, 2 pile, 3 pile, 4 piles, 5 pile, 6 pile, all these piles. All these piles are connecting to one pile cap. So this we call as a pile group. So for pile group, there are number of piles on the same pile cap. So due to stress overlap between these two piles, these are quite closely spaced, so overlapping would some occur. Some stress overlapping would occur. So due to this, the pile group, the load capacity of pile group, we can call this as Qg. That is not equal to n times the load capacity of one pile, Q allowable. So n is the number of piles. If n is the number of piles, and QA is the allowable capacity of one pile, QA1. So QG, due to stress overlapping, is not equal to entire number of piles. Actually, it is equal to QG is equal to n times Q allowable for one pile times efficiency factor, EG. EG is the efficiency factor for piles, and we can calculate this as EG is equal to 1 minus phi n m minus 1 plus m n minus 1 over 90 times nm. This formula we have to memorize. It is quite simple. So this is a formula for efficiency of a pile group. Remember, if the spacing is less than or equal to zero point 0.8 times that pile diameter, so we are going to use this formula. Otherwise, we are going, if the spacing is more than this, we are simply going to assume if the provided spacing is less than LB. So if we look at if we look at here, so if the provided spacing is less than this 8b, we are going to use this formula. Otherwise, if the spacing is greater than 8b, we are going to use EG as 1. If spacing is greater or equal to 8b, 8 times that pile dia, so we are going to use EG as 1, so efficiency as 1. Otherwise, if the spacing is less than that, so we are going to use this formula. So in this formula, what is this phi value? Phi is equal to tan inverse dia of pile over spacing. For example, if we move to this example, so here the dia of the pile is 12 inches. So the dia of pile is 1 feet. So tan inverse 1 divided by spacing between the pile is 3 feet. So spacing between piles is 3 feet. Tan inverse 1 by 3, we'll get the value as 18.4. 18.4 degrees. So this way we can get the value as 18.4. So now what is the n value? N value is the number of piles in one row. The number of piles in one row. So for example, in first row, if we check the piles 1, 2, 3, 4. So there are 4 piles in one row. So n value would be 4. Similarly, m is the number of columns or sorry, number of rows. How many rows are there? So the rows are 1, 2, 3. 3 rows are present. So m value is 3. So after getting this value, if we simply plug in this question, we'll get the answer as 0.71. If you plug in the values, you'd get the answer as 0.71. This is 4, 3 minus 1 plus 3, 4 minus 1, 490 into 3 into 4 into this is y is 18.4. Subtract from 1, we'll get this answer. So after calculating this efficiency, what would be our pile load, the load capacity of whole group? That is number of piles that are 4 at 12 times capacity of one pile times efficiency. Efficiency is 0.71. So if we provide the ultimate capacity as 100 kilonewtons, factor of safety as 2. So our Q allowable would be QU over factor of safety. That would be 50 kilonewtons. So Q allowable would be of one pile would be 50. So simply multiply them and we'll get this value of 426. So actually, if we multiply 12 by 50, we'll get the value of 600 kilonewton. So this, due to this pile, due to closer spacing between the piles, this capacity is reduced from 600 to 428 because stress is overlapping between the piles. Any problem in this calculating the efficiency of pile group? So last one is we have the negative skin friction. Second last one or the third last one. So skin friction negative. So negative skin friction. So what this says that if the sand sand type is loose or the clay type is soft. So if the sand is loose or the clay is soft, any of these cases, we are going to take their Fs value as negative. So whatever the Fs value we calculated, we will do the same procedure. Just we are going to take its Fs value as negative. If we are provided that the sand is loose or the clay is soft. For example, this is a pile. At the top, they are saying that there is loose sand. The second layer is soft clay, and the third layer is of hard clay. So we'll find its pile capacity like what would be its pile capacity Qu is equal to Qb plus Qs, and Qb is simply the base resistance. So Qb times AB plus now FQS would be for the first layer it would be Fs into AS, Fs1 into AS1, just like we did before. Just the difference would be it would be negative Fs minus AS. Second layer would be negative Fs2 AS2 because it is soft clay. The third layer because it is hard clay, so it would be again it would be positive and Fs3 AS3. Simply the difference is the negative sign between these two types of layers, loose and soft. Just this negative sign would be different. The rest of the whole procedure is same. This we have to keep in mind. Anyway, if we move onwards, the second last actually thing is this pile load test. So this pile load test, just go through this one. So we load pile, how much we load. It is written here that 2 times of design load for test pile, 2 times of design load, and for working pile 1.5 times the design load. And we apply increments in 25%. So just go through this all slides. It is written. So we apply some load in 25% increments. We have 3 dial gauges. We note these values and take those average. So when the load becomes constant, we assume that the all settlement has occurred. So we'll apply the second load. So we'll do this again and again until the whole load is applied 2 times of design load, and then we'll unload the pile again. So we'll get some graphs like this. We not know to draw them. This is all something. Just we have to keep in mind is this thing. What are the failure criterion? So the first one is the failure load which causes 10% settlement. For example, pile dia is 450 millimeters. So whatever the load which causes 45 millimeter settlement, that we would declare as the failure load for pile. The second one is if the settlement is not diminishing, the settlement is continuing on and on. That means that the pile has already failed, because if the pile has stopped, that means the pile is bearing the load. If the settlement is going on and on, that means the pile is not bearing load. It is going downward and downward. So that has failed. The third and fourth steps are important. That for these two, third step, they say that we have to, this is the pile load capacity curve. So for a third, they say that draw initial tangent to the curve, draw tangent to the initial part of the curve, and draw tangent to the final part of the curve. These two tangents. Where these two tangents intersect, check the load value. So these intersect at this point. So this is about 380, 390. This is about 370. So this is 370 kilonewtons. Is it in tons? Here written. So 370 tons. This is the third. The fourth criterion is the where the 6 millimeter settlement has taken place. So what we do, we go to this y-axis here. This is 6 millimeter. We draw a line parallel to the initial tangent of the pile load curve. So we draw a line tangent to the initial portion. So this is the tangent to the initial portion. So where this intersects, we take this value as failure load. This is 390 ton. So we'll get this 370 and 390. Take this average. We'll get the ultimate load as 370 plus 390 divided by 2. This average as 380. Now the allowable load is Q ultimate over factor of safety. If we assume factor of safety at 2, so this would become as simply 190 tons. So 380 by 2, that is 190 tons. So this way we can get the allowable uh, big pile capacity from pile load test. Any issue in this? Okay. So here we have the last thing for piles. So for piles, first we covered piles. Piles first we covered in sand, then we covered in clays cohesive, and then we covered uplift pressure, and then we covered CPT, then we covered SPT, and the afterwards we covered the pile group um, load, and afterwards we have covered this seventh thing as plate load test. Sorry, plate. I'm saying pile load test. So these all things we have covered. Pile load, group load. The last thing is the most important one. This is pile settlement. That how much pile is going to settle. So for this case, this settlement of pile group. So for this case, we are going to determine how much a group of piles would settle. So in this case, we have got this thing whole thing. So if we move towards this example, so they are saying we have square group of piles, 25 piles. So first of all, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So these we have this 5 by 5 pile square. So first of all, what should we do? We have to determine the group efficiency of this pile cap. So group efficiency is 1 minus psi, 1 minus phi, n m minus 1 plus m n minus 1 over 90 n m. Now in this case, n is 1, 2, 3, 4, 5. Number of piles in one row. N is equal to 5. M is the number of rows. 1, 2, 3, 4, 5. So M is again also 5. So the last thing is phi value. The phi value we know as tan inverse dia over spacing. Now we know the dia of the spacing. We would be given the pi of 0.6 meters in dia and space at 2 meters. So tan inverse 0.6 over 2. That would be like something like tan inverse 0.6 by 2. That is 16.7. 16.7 degrees. So this is whole things we require for group efficiency. Now group efficiency is simply and n minus m 5 I minus 1 plus 5 I minus 1 both are same over 90 into 5 into 5. So if we simply plug in the value 1 minus 16.7 into 5 into 4 plus 5 into 4 over 90 into 5 square, that is 0.70. 0.7. So the group efficiency is 70%. Right, so this step we have already gone through before. So the group efficiency is 70%. The next thing we have to determine is the capacity of one pile, Q allowable capacity of one. So we have to determine the Q allowable capacity of one pile. So what was the capacity? What we should do for this part? We have to calculate QB and FS. So QB is what type of strata is? They are saying that undrained shear strength at base is 175 and undrained shear strength over the length is 105. So they are saying that undrained shear strength, that means this is clay strata. So they are given the Cu value at base, that is 175. The Cu value at shaft, that is 105. They have provided this. At base it is 175 and at shaft it is 105. So base is QB CU. So 9 times 175, that will get for FS, that is alpha times CUS. So alpha we are given in this question as 0.45. Alpha is equal to 0.45. 0.45 times this 105. So we'll get this FS value. So after getting this QB and FS, now how to calculate the allowable QU would be simply QB plus QS or QB AB plus QS, sorry, FS AS, and Q allowable 1 would be QU over factor of safety. So this way we can calculate the allowable load capacity of one file, just like we have done quite much before. Any issue up till this part?
No.
Alright, so the group load. The group pile load would be simply like we discussed before. So QG we can simply write as n number of piles times Q allowable 1, the allowable capacity of one pile times efficiency factor. So number of piles we have 25 and allowable pile capacity is approximately 605. 605 and the efficiency factor is 0.7. So if we calculate this comes something like 10,600 something kilonewtons. So this is 10,600 5 units something like this. But we are given the applied load. Q applied is given as dead plus life, and the dead load is given. They are saying that permanent load of 9,000 the dead load is 9,000, the permanent load, plus the live load is variable load is 3,000. So 3,000. So that is actually 12,000 kilonewtons. So our Q applied is greater than Q of group. That is greater than the efficiency, the group pile capacity. So that means our pile would fail. It is not okay. But I have done some mistake here. They have written it as 13,238. If you multiply this simply this value, only this value, this answer does not come like this. So this is some problem here. So try to crack this one. So this pile would fail. They have said that check the adequacy of the pile group. Check the adequacy of the pile group against the load. So against load, our pile is failing. Against load, this is fail. This is not okay. So first we have checked the adequacy against the load. The second thing we have to do is to check the adequacy against the permissible settlement. So the settlement allowed SA is 50 millimeter. So now we have to calculate the total settlement in the pile group, and if the settlement is below this allowed one, that's fine. If it is also above this, so that means our pile will also fail in settlement as well. So the settlement of the pile. So if you remember, the total settlement consists of two types, that is intermediate plus the consolidation settlement. So intermediate settlement we covered in the mids. We covered three methods for that, like Jambu, that Timoshenko, and that was Schimmertman. These three methods we covered in the mids. So maybe this question may come and they may say that calculate settlement, immediate settlement as well. Why? Because 20% of mates is also included in the finals. So sir may put this part like this, that this may contribute to that 20%. So remember to go methods again, or simply for clay. If we move to the Jambu method, Jambu method is for the clay strata, and this says that mu naught mu1 q and b over es, that the immediate settlement si is equal to mu naught mu1 qn mu naught mu1 over es times q and b. This is the formula for this settlement. Now mu naught and mu1. Mu naught and mu1 we can get from this graph of mu naught and this graph of mu1. So df by b, if we calculate the depth of the footing divided by the width of footing, we can get this df over b. And if we calculate the height over the base, we can get this h over b. Using these and L over b ratios, and we can get this mu naught and mu1. And remember where we have to calculate this one. That for example, this is a group of files. For example, this is a group of files. So these are the length of the pile. So at 2/3 of this length, at 2/3 of length, 2/3 of the length, we are going to calculate these values. So at 2/3 of the length, what would be the pressure, contact pressure? That would be, for example, this is 8.6 meters. So we are assuming that for clay strata, that up to this 2/3 of length, the load varies with the slope of 1 horizontal and 4 vertical. So at up till this 2/3 of length, the slope is varying as 1/4. Just go through this 2-3 pages, like first page and the second page. They have explained all this thing, that up till this 2/3 of length, the load would vary at 1/4 of 1:4, one horizontal and 4 vertical. And below this one, like this, the load would vary at the slope of 1 horizontal and 2 vertical. So this way. So if the pile length is given in the question as 12 meters, so 2/3 of L would be 8 meter. 2/3 of 12 would be 8 meter. So up till this 8 meter, our load would vary as 1/4. So if we know the vertical value as 8, we can simply calculate this horizontal value. That this shows that if the horizontal is 1, vertical is 4. So at 8 vertical, automatically the horizontal would be 2 meters. And similarly 2 meters here. We are just using slope to calculate this value. You can do the whole method. So we can calculate this whole this width. This width is like 8.6 plus 4. This is 12.6 meters. So as this is a pile cap is a square footing, so our Q would be, because this is a square footing. This whole pile cap, this is a square footing, like this and this. So our Q would be total load. Total load we have as 12,000 newtons, kilonewtons. Divided by 12.6 into 12.6. So this way we can calculate Q values. We know the B value as this one, and you can calculate mu naught and mu one from those tables. And we have to do this for we have to make a sum this way, that our height of the file group is 16 meters below that, and the B is 12.6, just like we calculated like this 12.6, this way 12.6 we have calculated. So if we divide H over B, we'll get the value as 1.3. So we'll divide H over B, we'll get the value as 1.3. So approximately like here. And we have uh, L over B ratio as 1. Why? Because this is a square footing, so L over B ratio is 1. And D over B, the depth over the width ratio, that is 0.7. D is 9 meters. And why D is 9 meters? Because 8 meters is up till this portion, and they are saying that this pile is lying 1 meter below the ground surface. It is written in the question that this pile group is lying 1 meter below this pile. This is 1 meter. D, that the depth 9 meters. 8 plus 1, 9 meters. Width of L over B ratio is 1 and all that. So if we move to this chart, Jambu 1. So L over B ratio is 1. So we'll move to the square one and we'll calculate this one as 0.5. So mu1 we have as 0.5. DF or B ratio we have as 0.7 only. We'll get 0.95. So simply use these values. 0.93 they have used and 0.42. So approximately these values. Simply you can round the 0.95 and 0.5. So simply calculate the immediate settlement like this way. So addition in this. So last thing is this one, the consolidation settlement. So we can go through this one after doing this consolidation. So should we continue this consolidation part now, or should we do this tomorrow? Here's some small portion. If you want to, we can do this tomorrow, and I can give some overview of payment part tomorrow. Should I continue now?
Are you tired now? So we are not tired. We will continue.
Quite a
Otherwise,
different concept from the pile, so it would be
okay.
mixed. So
Okay, then we will do it tomorrow. Do you have time?
It will hardly take half an hour, and something like
Okay.
Then if you have time on tomorrow, then we will continue on tomorrow, Anush.